AI has made its way into charting, radiology, pathology. We had a prior episode on GI, and it can help us with medical decision-making. But what about procedures and surgeries? When can we expect that autonomous robots will be assisting us with surgery and maybe even taking it over completely? Surgeons, proceduralists, are your jobs at risk? Let's find out. Dr. Michael Yip is an associate professor of electrical and computer engineering at UC San Diego and director of the Advanced Robotics and Controls Laboratory, ARC Lab. His group currently focuses on surgical robots, biomimetic design, and robot learning. His research has received several Best Paper Awards and nominations and has been recognized by the NSF Career Award, NIH Trailblazer Award, and as a RAS Distinguished Lecturer. His research has led to the foundation of startups, and he was named the Faculty Innovator of the Year at UCSD in 2024 and elected into the National Academy of Inventors. Dr. Yip was previously a Disney researcher in 2014 and Amazon Robotics in 2018. He received his Bachelor of Science in Mechatronics Engineering from the University of Waterloo, an MS in Electrical Engineering from the University of British Columbia, and a PhD in Bioengineering from Stanford University. First, a word from our sponsors. You're listening to Succeed in Medicine, the show for practicing physicians who want to master the parts of their career and life that med school never prepared us for. From interpersonal skills to career navigation to the essential information every physician needs. I'm Dr. Bradley Block, and in every episode, we bring you brass tacks advice and immediately applicable insights from world-class experts, so you can feel prepared wherever your MD takes you and build a life in medicine that's sustainable, rewarding, and actually worth all those years of sacrifice. Dr. Michael Yip, thank you so much for being on the podcast.
Hey, thanks for having me.
So, first question is, if you had a friend or family member, knowing what you know about surgical robotics, autonomous surgery, where we are, if you had a friend or family member that said, you know what, I'm thinking about going to medical school, going into surgery, what would you tell that person knowing what you know?
Yeah, if I had a friend that was thinking about medical school and they were going to ask me about robotics, I basically would tell them, like, robotics is certainly a tool that's used in surgery, but it is a technology and a tool that is going to keep growing and going to be more and more in the everyday life of, a surgeon and a surgical team. And they absolutely should be getting their hands on as soon as possible and across a diverse range of technologies as possible in the robotic space in their practice and their education.
So what I'm not hearing is, don't go into it. Y'all are going to be obsolete very soon. You're going to be replaced by AI and autonomous robots, and you're not going to have a job. You didn't say that. What you said is there are going to be a lot of new tools that you're going to need to get used to using because they're going to be it's going to be a very necessary part of your life.
Robotics today is about an extension of a human operating surgeon, right? They're using robots in a teleoperation capacity to augment their skills to be more precise, to improve the level of dexterity they have while performing procedures, to improve their visual understanding of the environment. And the reality is that we have only a limited set of surgical robots out there right now for certain types of procedures. And there's so many different procedures that are just asking for better robotic tools that haven't come along yet. And so there's still a huge gap from like the transition from the use of robots as tools to the use of robots as autonomous doctors or nurses that will end up performing procedures by themselves. Now, the question of, will that happen one day eventually? Now, that's an interesting question. And I believe, yes, it will happen eventually, and happy to kind of walk down that thread. But I think that there is going to be quite a transition period before that happens.
Okay, so right now it's a tool, and for today's surgeons, we don't have to worry yet about being replaced, but it's eventual. And I think, like, if you think about autonomous cars, right? There might be a day where our kids go, I can't believe we let humans drive cars. right? That
Absolutely.
seems,
Yeah.
nowadays, it seems just ridiculous. The imperfect decision making of humans and our recklessness. And clearly we're not there yet. And so that day will be eventually. So I think let's just start with the fact that you're referring to it as a tool. And I think a good similarity is, if I remember from my general surgery, I'm an ear, nose, and throat doctor. So, we don't really use, the head and neck cancer surgeons will use the Da Vinci robot to get to like the back of the tongue, to get to other inaccessible places, but it's not really heavily utilized in my field. But if I remember back to my general surgery days when I was an intern, there's a surgical stapler. And what it does is it staples along the sides and cuts simultaneously with a lot more precision than if you were to like hand cut and hand sew everything. So it saves you surgical time and it improves outcomes. And so it sounds like we need to start thinking about robotics more like that.
Absolutely. And actually, maybe I can press on that because these surgical staplers, right? You can imagine that a surgical stapler being a pretty sophisticated piece of equipment that doesn't come cheap, right? And that requires resources to both acquire and, either maintain, and then eventually you have to discard it. Some of these are not reprocessable. And so what if you could actually save the hospital, the patients, the cost of these very expensive pieces of equipment, thousands of dollars, of course, by having the robot itself learn how to suture, right? And suture well. I think that there's a lot of value in that. And so we're not talking about completing a procedure end to end. We're talking about autonomy slowly creeping in these fine cases where, hey, why not, right? Like there's actually value here that you can return to the doctors and the patients and the hospital networks and so on and so forth.
So can you give us examples of what is being done right now, where we can look forward to utilizing these technologies in the near term?
Yeah, so we touch on soft tissue type of procedures, right? With suturing, being a task that you do with soft tissues. I would say like right now, a lot of the autonomy that's happening is in hard tissue space, right? So bones. So the Mako surgical robot or the Stryker robot, those are bone milling robots. And, when you have something that's like a CNC mill and you have a bony structure that is rigid, that makes a lot of sense. And so you can basically autonomously mill out to better accuracy than a human could possibly do with hand tools, a socket for an implant, right? So that's
So
already
you're
out
preparing
there.
a socket for an implant, like for a hip replacement.
Yeah, for hip replacement, knee replacement, right?
Okay.
And like you can imagine like the similarity of doing machine made furniture than handcrafted furniture. Yes, some people are amazing, and they can do really beautiful pieces. But if you want something that has a perfect socket, right, you're just going to have a machine do it,
Yeah.
right? And so that's out there, right? And that's really being in use in many ways. Now, there's also another thing that's out there, right, which is focused radiation therapy, right? And so things like the CyberKnife is a focal radiation where the beam is controlled by a robotic arm, and the robot arm is within a software stack that actually tries to find the best locations for the beam to swing around and focus the radiation so that it maximizes the focus of the radiation on the lesion, minimizes collateral damage. And that's all pre-processed. So that is autonomous, basically, right? You hit go and it goes and does it.
Yeah.
Right. And so autonomy is here. Now, that's like the CyberKnife is this, like, we're not touching the body, like physically, just through radiation. And then you have like hard tissue autonomy.
Yeah.
Now, soft tissue autonomy, that's where it gets really hard, right? Because things shift as you interact with it. And where we are going to see, the use of automation, in my opinion, coming into soft tissue surgery are for relatively blunt type of interactions with tissue, like retracting tissue out of the way and holding them out of the way, using a robot arm.
What are our med students going to do?
Exactly,
Then,
right?
right?
Yeah.
They'll
Like,
learn.
how are they going to do their like upper body, like isometric training, holding tissue open for hours, right?
I mean, it's ultimately hazing. So if we can get that out of medical education and have them utilize that time learning, that would be just great for everybody. Yeah.
Yeah, absolutely. And autonomy is, I think, the easiest and perfect first application.
Okay.
Yeah.
Well, I don't want to name drop who may be your competitor, But wasn't there someone who just had an autonomous robot suturing bowel?
Yep. Yep. People have been doing or demonstrating autonomous suturing for 15 years.
Really?
Yeah. And so the
So then what's
difference,
the barrier? Like, how come this is not something, if it's been around for 15 years, how come it's not something that's currently being utilized?
yeah, so the reality is that it's really easy to make a video and really easy to make one in an engineered setting where
Yeah,
everything has been highly structured and regularized. But in a real operating room and with real patients, right, that's a completely different story.
got it.
And
So,
so many more variables. And what really happens is that we have all of these new techniques coming out from, deep learning and like LLMs and vision. And every time we have a new technology, we say, well, how can we use it to kind of show the same application? So that's why over 15 years, we kept seeing these demonstrations of, not to harp on suturing, but it's the most visually, appealing and understandable.
look, this robot tied a knot.
Yeah,
And
yeah,
again,
exactly.
and another one. Yeah,
Yeah. So we see the same kind of videos, but just with different techniques. Now, if you take any of those videos as time point, you say, how far are we from what that video is showing and actually getting it into the operating room? I think, in my honest opinion, we are no closer than the first videos than the videos today. And so the reason why is because going from demonstrations of something like autonomous suturing in a structured setting to one that's in the operating room ends up being a really deep, like, engineering challenge that requires a ton of capital. And so what has to happen is that there has to be an economic incentive that is very, very strong for you to deliver a robot that, instead of it being a specialized tool that does, the suturing and closing tools, there has to be a very strong economic incentive for it to have an autonomous process to do this. And then companies will put in all the money to do the engineering to provide that as a solution.
so there's not enough money in suturing.
Yeah, I think that's one of the major problems.
I guess what you're saying is they're doing it every time there's a new video about it. It's just to draw attention to the technology. Here's what we can do. It's like marketing, but not actually moving forward with solving the problem.
Yeah, well, I think it's kind of flips two sides of the coin, right? So for the practitioners, it kind of is kind of a marketing thing. But for the scientists and the engineers, it's to say, like, hey, here's a new tools on tools, right? Here's a new tool that came out, whether it's LLMs or something like that,
Yeah.
right? That we can use, and it happens to also work in this application case.
Yeah.
Now, what does it take to get there? That's a really long journey. But
Got it. But there was just the situation, right, at that lab at Hopkins where they were suturing, I think it was pig bowel, like an anastomosis, which is a big deal because an anastomosis, right, when you're anastomosing bowel, if you tie the sutures too tight, you can necrose it. If you put in too many sutures, you can necrose it. Not enough, not tight enough, you get a leak. And that is very expensive because then that patient has a long hospital stay, could lead to sepsis and death, right? That is very expensive.
Yeah.
And so there's a use case there where you could be saving a lot of money. And so what's then the barrier to that specific situation being applied in the operating room? Or it's the same answer?
Yeah, I would say that. So again, it is like a long engineering journey to go from, the video demonstration and in a environment research setting into real world. Now, like you said, there's actually a lot of incentives kind of for this to transition. And so realistically speaking, yes, people are working on trying to make this happen. People are putting in money nowadays. VC firms are looking at autonomy and surgical robots as a potential avenue. Is anastomosis a right choice at first or not? Everybody has a different opinion. But yes, people are recognizing that this is a real opportunity. And I will say that, again, with the different tools that have come out that have been used to demonstrate automation in surgery, back in the day, we didn't have very strong computer vision tools. We didn't have LLMs or VLMs, but today we do have it. The shift has kind of gone from geometric and kind of more mathematically based approach to solving autonomy to one that's purely about data, right? And the challenge with data, especially in a life and death scenario, is that when you use machine learning to learn a model from data. Anytime you are falling outside the distribution of the training data that you've learned off of, the model can behave very erratically, right?
Yeah.
And the problem with that is the model doesn't know that
Yeah.
it's behaving erratically.
Right.
So how do you know when it's behaving incorrectly? How does it know when it's behaving incorrectly? Whereas classical methods, right? I mean, they are pretty mathematically principled. You know that this is kind of, you're in a region that this has never seen before. And so, or the math is not modeling.
Yeah.
It's a little bit more nebulous today to figure out, I'm here, this is my demonstrations, I've shown it and achieved it in the lab, to how much data do I need to collect? Like, what is the variety of data I need to collect before I'm very confident that it can really work in real life? Yeah.
I guess if you can do it in a llama, a pig, a gerbil, and an elephant, then you can probably do it enough variables in there. If you like this podcast episode, you're going to love the other shows over at the Doctor Podcast Network. For instance, The Purposeful MD. Dr. Laura Sutton, who was previously a guest on this show, helps you rediscover your passion with The Purposeful MD. She guides you through overcoming burnout and finding fulfillment in your medical career. It's time to practice medicine on your terms. Subscribe and embark on a journey to a more purposeful practice with The Purposeful MD. So then, where are we close? You're saying there are situations where we're far, right? And there are situations where we're already utilizing it in the case of hip replacements. But where do you think we're going to see it next? Where are we on the precipice of a new tool in surgery or other procedures?
Yeah. So I think the way to look at it is in a procedure where you have actually, you basically, for lack of a better word, require a lot of hands, right? So you need certain assistance by your side, and like you start stacking more and more people all together.
Like the retraction.
People,
so you're saying basically like a step more than retraction. I mean, I can't, I guess like suctioning.
Suctioning. So we've demonstrated autonomous suctioning for this very reason, right? And autonomous retraction as well. But the idea that there's all these tasks and there's a different hierarchy of what is challenging, what's like easy, but they're all tedious. Right? They're all like physically demanding. And the ones at the bottom, those are just prime for a robot to just kind of take it on.
I like how you use the word hierarchy, because if you think about it, like that's what surgical training is, right? Where the med students are going to get replaced first with their retraction. And then the interns are going to get replaced next with their suctioning. And then the next step is going to be like simple suturing situations, right? Like, and then the next step, right? So as you go through the more sophisticated training, you're replacing, like that's the stepwise fashion that things are going in. Okay.
Yeah. I think for most of the part, as you go up that ladder, you can ask the med student, like, do you care that the robot is holding this open versus you standing there for hours?
But med students are cheap. You're not saving money, right? Med students are cheap. And I think in a situation would be like rural situations where you don't have med students, where you don't have as many assistants. And so you'll need...
That's a perfect like jumping off point to like the value of robots for telemedicine and telesurgery.
Yeah.
And also even more so like the idea that really in telesurgery, it's always one human to one patient. And if you don't have enough humans operating the robots, then you basically don't have more patients getting treated. And so it kind of leads to autonomy as a way to meet the demands and addressing the demands of the surgical needs of rural and remote communities.
Okay, so what you're saying is replacing some of the simpler stuff. Like one question that I was going to ask is how far are we from skin to skin surgery, where, the incision, opening the skin and then closing the skin and everything in between is done by the autonomous robot. But what you're saying is something like the closing of the wound, which is not going to be that complicated, we can maybe hand that off to the robot so that the surgeon can go in the next room and take care of the next patient. So we're freeing the surgeon up. I mean, I think the complicated part of that is that often that's done by like a physician's assistant, right? You can have someone who isn't as highly trained as the surgeon themselves. You can hand off that stuff already. So even in those situations, is there really a financial incentive for these companies to do that?
Well, I think the interesting point is that what's going to happen is in the current way, the number of doctors and the number of trainees that are out there and how fast we're training doctors or surgical techs and so on and so forth versus how quickly this demand for surgery is growing. If you take a surgeon assistant out from closing up, right?
Yeah.
They're not going to be sitting around twiddling their fingers. There's certainly going to be more people that they could now help.
Yeah.
And so I think if you look at the population kind of side of like surgery, yeah, nobody's going to be at a lack of things that they have to, use their skills to do.
Okay. So I see what you're saying. We've got a finite or a growing amount of work that needs to be done. And the more that we can offload that work on an autonomous robot, the more it frees the finite number of work hours that we have available per worker. It frees them up to do other things, and it's up to us how to utilize them.
Absolutely. Yeah. I think it's very telling when like governing bodies, right, have to put a cap on the number of hours that people are allowed to work, right?
Yeah.
Because the demand is just so high. And, anecdotally, I've had surgeons tell me that they don't want their children to get into this space because it's such a demanding job and it takes over. And so that's kind of where we're at today, right? And so this technology can really help alleviate that burden of ever-growing amount of work that needs to be done.
So some of the barriers right now are engineering barriers, and we've discussed that. There are other barriers that are economic, right? Putting enough money into the research and developing the models so that it can work. Other barriers that I can think of would be adoption by surgeons or regulatory, right?
Yeah.
And so let's think about regulatory. What barriers are there that you're familiar with, that you're aware of, that could be impeding utilization?
Well, first of all, the actually very pragmatic barrier is that the FDA does not have enough experts to really properly adjudicate all of the submissions that they're getting on the AI space, right? Not just even in surgery, but like in general, they just do not have enough experienced experts in AI to be able to adjudicate it properly. So number one, they have to figure out how to adjudicate things properly. And there are both political reasons that's occurring, but also just the reason that this field is exploding. And even if there wasn't any political limitations, there's just a scale at which agency can grow, right? So that's probably, honestly, the number one factor that these things are right now seeing a huge barrier to entry. But then over time, that barrier will shrink. And then the next one will be about looking at the current way things are going, like we talked about data and how it's in many ways, models learned off of just purely data is in many ways unexplainable. And so you don't really know when the model is going to predict something it's never seen in a training data set.
Yeah.
And it has no idea if it's confident or not about that. Most models aren't. And so there has to be new metrics that are established from the regulatory bodies to say, well, what is safe, right? Like, what do we consider safe? Is it a probabilistic safety?
Yeah.
Instead of saying like, hey, my robot, it can never have more than like 2 millimeters of error in its movement. You kind of have to flip that around and be like, instead of saying it can never have 2 millimeters of error, and this is a very trivial case, but I'd say like, it can never do anything wrong 99% of the time. And the 1% of the time it can do wrong, is there a metric on that? Like, could it just completely...
What is wrong? Yeah, how are we defining wrong?
Right?
What is acceptable wrong and what is unacceptable wrong? I
Right,
mean, I think
right.
we have precedent for that in medical malpractice, which is if the patient is injured, then it's an unacceptable wrong. But if there's no sequelae and, there's an error, you can't sue someone for making an error if there's no injury. And so I think we can let the lawyers lead us in that situation. And the other is the liability, right? The company, as long as you can sue the company that's making this device, if an error occurs, the company is then incentivized internally to make sure they'll have their own financial incentives. Well, we know that we're going to get sued X% of the time for their errors, and we're getting paid Y amount. And so per our calculation, this is an acceptable error rate because of the amount of money that we're making and what we expect to pay out, right? That's how they're going to make their decision, which is why, to your point, we need the regulatory bodies to also make a independent decision on how we're defining safe.
Absolutely. And then the other thing is, again, like accreditation, right? Bodies saying, and licensing bodies, right? So if you're talking about remote surgery, your ability to jump into a case in your hospital network, out of hospital network, and then out of state, right? How does that look, and what are the guide rails around that? And
so the robots need to get individual accreditation per state.
Well, yeah,
just like
yeah.
I do.
And companies like Savado are looking into this.
Interesting. That's something that I never thought, because it's a tool, as you said. So why would accreditation differ?
Yeah. And so it's actually ending up on the physician side, right? Like, how do you look at that? Because again, not only are you talking about different requirements of, and different licensing bodies, but also different networks, hospitals, liabilities that get split. And how do they get split? A lot to sort out.
Yeah. The legal system gets hairy. Final question.
Sure.
And this is where I'm asking you to look at your crystal ball, right? We talked about skin to skin surgery. So let's say a simple, straightforward laparoscopic surgery that needs to be done skin to skin. Appendectomy, cholecystectomy, apologies to my general surgery colleagues, or maybe let's even say something like a lipoma excision, something that's just under the skin. Let's not even go laparoscopic, just under the skin, superficial, no vital structures in the area. How far are we away from an autonomous robot prepping the skin, making the incision, taking out the lipoma, closing the skin?
So the reality is that the type of robot that we're considering here is actually really important. And what you've described is conditioned on, do we look at teams of robots or do we look at one robot? Because I think that if we look at a team of robot where a robot is specially designed to deal with just external kind of interactions with skin and things that require much larger forces, and then a separate type of robot that deals with a different part of the procedure that requires finer tissue, soft tissue manipulation. When you look at it that way, I think the reality is that autonomy can probably be achieved relatively soon, in a couple of years, right? We just need to kind of pull, all these components together and give a demonstration of that. Now we hit the issue again of that's a demonstration. If we talk about going all the way down to clinic and real, like transferring it into the real world, you have all the issues we brought up before.
Yeah.
But the thing I want to press on was that, one of the biggest barriers is that no robot right now is anywhere capable of the combination of both the amount of strength and dexterity that we have as humans, but also the fine motor capability and detail that we can do as humans. And so if we look at like procedures end to end, you're just mixing all of these things together, and you need a robot that's both strong and has large kind of workspace, but nimble and very precise, and it doesn't exist. And so if you take it apart and you say, well, we have multiple robots for every part of the sequence of steps that needs to be done, we'll automate every sequence of those steps with each individual robot that's designed to be really effective in that stage, and we'll be able to show it. But if we're talking about like a humanoid robot coming in and doing the entire procedure, the hardware is not there.
Yeah.
We are limited by material science, physics, all of this right now. And that will be many, many, many years down the road.
Okay. So for reasons that you said earlier, you kind of answered the question twice about if a family member was asking you if they should go into surgery. Your answer is it's going to be many, many years before their skill set is going to be replaced. But for other reasons, all the stress that we're under, et cetera, those were the reasons. That's what you touched on earlier, why you think you might not recommend someone go into that field. So not from what you've heard from friends and family, rather than what you know as an engineer.
Absolutely. And, the types of surgeons we work with are academic surgeons. And I have seen in the past, let's say 5 to 10 years, a really drastic shift in everybody's both acceptance and excitement about robotics and autonomy and what that could bring to what they're doing in their own practice and how they can help more patients than they can do by themselves with their own hands.
Amazing. Michael, if people want to learn more about you, where can they find you?
Yeah, you can find me basically if you look up Michael Yip on Google. Our lab
You're
is
the
at
first one
UC
to
San
come up.
Diego. Yes. So I run a research lab at UC San Diego, and you'll find our contacts there and also the research that we're doing.
Fantastic. Well, thank you for all the work that you're doing, because, each discovery is going to help so many patients. And thank you for talking to us.
Great. Yeah. Thanks for having me on.
Thanks for listening. I have a favor to ask. You listened to the episode until the end, which means either you fell asleep or you really liked the episode. So please write us a 5-star review, take a screenshot, and email it to me so I can send you a quick guide on how to earn patient trust in 20 seconds or less. Email me at brad@physiciansguidetodoctoring.com and feel free to suggest a topic or guest. I take your requests seriously. The views expressed on this episode are those of the interviewer and the interviewee and do not represent the views of their employer or even their significant other. Even though the magic of podcasting makes it sound like I'm talking directly to you, this is not a doctor-patient relationship, and this is not medical advice, or financial advice, or legal advice, or really any advice. Thanks again for listening to Succeed in Medicine.